the open-closed principle. Open to extension, closed to modification. Personally, I don't really like the name of it. I don't think it's very clear. So for the purpose of explaining, let's call it temporarily the generic specific principle. It's to do with abstract classes and using abstract classes as base classes so that we can pave the way for object-oriented code reusability in the other principles. Let's see how it works. Basic one would be animal and giraffe. A giraffe is an animal, right? So let's draw in our lines of inheritance here. Solid line and open arrow, meaning a giraffe is an animal. Giraffe extends animal. And in this case, animal is an abstract class, meaning it can't be instantiated in and of itself. And that makes perfect sense, because an animal can't possibly be an animal unless it's a specific kind of animal, right? There's no such thing as an animal that's just an animal. It's always got to be a certain kind of animal. So that makes logical sense there. And what that means is we can pass in giraffe as an animal to a processing service that deals with animal, and that gives you reusability, because we'll be passing in giraffe, of course, as an animal, and we'll be passing in rhinoceros as an animal, and we'll be passing in all of the animals as an animal so that the processing class can deal with animal. And that gives us reusability. Now the same is true for our service classes and processing classes as well. Consider the admission service, the animal admission service. It's what needs to happen when an animal is admitted to the zoo from another zoo or wherever it comes from. But what if we made the admission service an abstract class, a class that couldn't be instantiated on its own, a generic class? Then we could extend the class and have it different for each one of the zoos. Maybe we've got lots of different zoos. So this is the Sydney Zoo admission service. And that extends that like that. And in that way, we get code reusability. We don't have to have a completely separate system for every one of the zoos now, because we have this generic admission service that's very happy to accept animal as a parameter and deal with animal. And we've got loads of different animals that are very happy to be treated as an animal when they get passed into the admission service. So in that way we get code reusability among our entities here, because we've used the generic specific principle, and we've got code reusability between our zoos because we've used the generic specific principle. So why is it called the open closed principle? It's not called the generic specific principle at all. Here's the answer to that. When you're implementing a system, effectively at design time, when you're designing your objects, you should go for this idea that some of your objects in these abstract classes shouldn't need modification when you're creating your system, when your system is running. Yeah? So this is the basis of the concept of a framework, actually. This area here would be your framework. You've got your admission service, which is generic. You've got your animal, which is generic. If you want to implement the specifics, your specifics, then you need to implement giraffe. You need to implement Sydney admission service for Sydney Zoo, for example. Contrive a situation where these are closed to modification, but very much open to extension. And that's the open close principle. That brings us on to the next one, which is Liskov substitution.